Hello everyone. So today we'll discuss the previous year question of Sedimentary Petrology, GSI Prelims. So we'll start from 2023. But 2024 we have already made a video, so you can check that on YouTube. So first question: which one of the following statement regarding a Rose diagram are correct? So Rose diagram, this diagram are used to determine paleocurrent direction. So the intervals of azimuth are plotted as pie-shaped segment of a circle in their true orientation. Generally, in Rose diagram, the directions are plotted like this. So this is a pie-shaped thing, and it is plotted in their orientation or in their direction. It is correct. The length of the radius of the circle is not proportional to the frequency of measurement. So the length of this pie-shaped thing, it always corresponds to the frequency of measurement. The number of measurement we have taken, that corresponds to the length. So it will be incorrect. Rose diagrams are used to display feature as directions of sediment transport and strike of vertical joints. So it is used to determine paleocurrent direction. So it is used to determine the sediment transport direction, and also it is used to determine the strike of the vertical joints. The Rose diagrams are histogram for which the orientation of axis transfer into a circle to give true angular plot. So it is, in case of Rose diagram, it is an histogram where the axis, it is mathematically it is transferred into a circle to give the angular plot. So we will know the particular paleocurrent direction. So here, except the number 2 option, all are correct. This is incorrect, and 1, 3, 4 are correct. So answer will be B. This also grain size sorting is extremely poor in. So it is a very common question. So you know, glacial deposit, it always yield very or extremely poor sorted metal. It will find all type of deposition starting from boulder to clay type of sediments. So grain size sorting, it is extremely poor, will be in glacial deposit. So answer will be B. So which of the following type of grain contacts signifies maximum amount of compaction in sandstone? So you have different types of contact in sandstone or in grains, like your point contact or float contact, long contact, concave or convex contact, then your suture contact. So from which suture is a maximum contact where it is produced by solution or pressure solution. So you see the options: concave or convex contact, suture contact, long contact, point contact. As you say, the suture contact, it represents the maximum compactness. So the answer will be suture contact. In a sedimentary rock, different proportion of gravel, sand, mud-sized grains are present. What should be the minimum required volume percentage of gravel components to classify that rock as a conglomerate? So remember, any type of rock, if you consider them as a conglomerate or breccia, it should contain more than 30% of gravel material. That is, it should contain more than 30% of sediments that contain greater than 2 mm grain size material. So then we will consider them as conglomerate or rudiceous rock, you can say conglomerate or breccia. So which one of the following biogenic structure can be categorized as bioerosion structure? So bioerosion structure. Biogenic structure, it can classify it into 4 types, you can say. One is your bioturbation structure, which include burrows, tracks, trails, then some root penetration structure. Then biostratification structure, you will consider stromatolites, Sometimes you will find biological graded bedding. Then your bioerosion structure. So bioerosion structure, it consists of boring, scraping, biting. Then your coprolites, it is fecal pellets. So here bioerosion structure, it will be boring. Boro, it will be it will be biotorsion structure boro, and bioerosion will be boring. Fecal pellets, it will be coprolite. Then biostratification structure will be stromatolite. Their answer will be boring. In modern ocean basin, zoophycus occurring. So zoophycus are, you can say, facies assemblages or trace fossil assemblages, you can say, or trace facies, you can say. So they are basically found in bathyal zone. In bathyal zone, in deep ocean condition, they are found the zoophycus. The answer will be bathyal zone. Which one of the following sediment structure provides sense of direction of grain movement? Sense of direction of grain movement means in what direction the grain is moving. It is a grain movement direction. So grain movement direction, generally it is known by the marking structure. But you will take the example of bounce mark, prod mark, then your Bros mark. They always show the sense of direction of the grain move. Sense of direction of the grain. Other structure we use to determine the movement or direction of flow. So the grain movement direction, it is known by prod mark. Then also the crystal fragments, glass fragments, rock fragments that have been released from pre-existing volcanic rock by weathering or erosion and transported from their place of origin by air, water, ice are known as. If volcanic matter they are drifted, if volcanic matter they are drifted from their places, they are called as epiclast. They are called as epiclast. The material that is erupted from magma, or the solid fragment that is erupted from magma, they are called as pyroclast. But if they are drifted from one place to other, it is called as epiclast. And autoclast, it is like orthochemical thing, it is in situ thing, where it is deposited at the place of its formation. So answer will be epiclast. Then a grain supported carbonate rock with intergranular spaces occupied by clay and fine shield size particles. So first thing, a grain supported carbonate rock. So we have two grain supported carbonate rock according to Dunham's. One is packstone, another is grainstone. So grainstones, it contains no mud or very little amount mud, less than 10% mud. Packstone contains more than 10% mud. As it is asking the intergranular spaces that is occupied by clay and fine shield size particle. So it is indicating that it contains mud, so it will be packstone. So answer will be packstone. Then epsilon cross stratification is characteristically found in epsilon cross stratification. It is found in Meandering River. It is found in Meandering River at the point where deposition. So when there is a sudden surge of flow or increase of flow velocity, then a river cannot take this meandering path, it will take a straight path. So during this straight path, it will produce a cross bedding. That is called as a epsilon cross stratification. So it is a very characteristic feature of meandering channel. The answer will be meandering channel. Debris flow products generally assume which one of the following geometry. So a debris flow. So normally it will look like this. It is flowing through a slope. Look like this. So it has a flat base and convex top. There is a flat base and convex top. Answer will be flat base and convex top. So you can refer any diagram from the internet. Which one of the following feature bears the unequivocal signature of an aeolian deposition? So first, common presence of ripple drift. So ripple drift, it is a most important characteristic of, you can say, for alluvial condition. Then presence of particlination. Particlination also it represents flow velocity. It is related to alluvial condition. Then regular alteration, grain fall and grain flow strata. So fall and grain flow strata. These are strata that are, you can say, large scale tabular cross strata. They show alternative finer and coarse grain condition. So grain fall is like when it will deposit at the crest. It is produced during the migration of transverse dune. So when it will deposit at the crest, it will fall. Sorry, it will flow. Then grain fall, it is the suspended particle, they will fall. So these are characteristic of a aeolian condition because they are produced during the during the migration of transverse dune. So grain flow layers, they are created by sand grains. They flow down the slope, and the grain fall, they are created when sand grain that is in suspended condition, they drops from the air. So it is very much characteristic of a aeolian condition. So answer will be C. Poorly structured, it will be incorrect because aeolian depositions are very well structured. Then all calcium carbonate sediment with their original mixed mineralogy after diagenesis, they will convert it to, if they all will mixed up. So calcium carbonate sediment and with their original mixed mineralogy after diagenesis, when they will transfer into low magnesium calcite. They will transfer into low magnesium calcite. So answer will be low magnesium calcite. Then the principle that phases which occur in conformable vertical succession of strata also occur laterally. It is the statement of Walther's law. If you find the faces vertically, you will also find the same faces laterally. Where there is a break in faces vertical sequence, you will also get a break in faces in the lateral section. This was from 2023. Then comes to 2022. The sharpness and pickedness of grain size frequency curve is referred as. So sharpness or pickedness, it is like this. This is a curve that represented by kurtosis. Skewness measures the degree of symmetry. The answer will be kurtosis. Consider the following statement regarding original and distribution of different sedimentary rocks through geological lens. So I have to say which one is correct. So relative volume of shale per unit age has remained nearly constant since Precambrian. So relative volume of shale, because shale generally it is produced by erosion, weathering and erosion. So with time, the shale that is converted through metamorphic rock, metamorphic process also formed by weathering process. So mostly you can say they are remain constant. Iron-rich sediment rock preserved per unit age have been decreased in the post-Precambrian time, because iron-rich sediments, they are produced as a particular environment. So as we are gradually extracting all the iron, so gradually they are decreasing with age. So it is also correct. Preserved carbonate rocks per unit age have decreased in the post-Precambrian time, because after Precambrian time, the carbonate deposition gradually increases because that is the availability of organism after Precambrian time. Precambrian time is Azoic. After that we have Phanerozoic. So in Phanerozoic we will get more carbonate rock deposition. So it should increase. So that's why this will be incorrect. So the answer will be 1 and 2. These two are correct. 1 and 2 are correct. Then comes to intercrystalline porosity represents. So intercrystalline porosity means in between crystal. So intercrystalline, it is a porosity that form between the chemically formed crystal. This is the pore spaces between the chemically formed crystal or chemically precipitated crystal. In them, the porosity is called as a intercrystalline porosity. So the depth to which surface waves affect a water body is referred to as. So the depth to which a surface wave affect a water body, it is called as your wave base, which is generally the wave base. It is half of the wavelength. The wavelength, the depth of the wave base, it is half of the wavelength. Which of the following is a diagnostic features of wave ripple cross bedding? As a chevron upbuilding of foreset, also a diagram. First option is your chevron upbuilding foreset. So here the foreset will dip in both directions because it is a wave ripple cross bedding, and they will upbuild like this, a chevron shape. So it is called as a chevron upbuilding. Then we'll move to next option, that is bundle upbuilding. So they will bundle up towards the top. The foreset will bundle up towards the top, and offshooting and draping. Offshooting means they will like diverge from a point and they will drape also. Drape is like we were bundling things, that is draping. And you will also get a lenticular set, solid lenticular set, that is your placer thing or deposition of clay. So all these things, they are the characteristic of a wave ripple cross stratification. That's a characteristic of wave ripple cross stratification. So answer will be D, 1, 2, 3, 4 all. And consider the following statement regarding reactivation surface in a cross strata set. The attribute to the modification in previously formed bed. So reactivation surface, it is found in your tidal environment. So they deposit on a eroded surface. So during the formation of reactivation surface, so there will be a modification of previously formed bed. That is the erosion of the previously formed bed. So they form due to erosion by wave or current, which is they form by erosion of wave or current, that is your flood current or eve current, that is during flood tide and eve tide. So one of them will be your stronger, so that will produce a cross bedding. So during a return current, it will erode the general formation of a reactivation surface. Again, on that eroded surface, the cross bedding will form. So they form due to change in flow direction. Obviously, they form due to change in flow direction. They form due to erosion resulting from interaction of bed forms. So obviously, they are formed due to erosion. So reactivation surface, it is actually a cross bedding deposited over a eroded surface. So a cross bedding is continuing deposition here, like this. Suppose a cross bedding is depositing like this. So current is flowing in this direction. So it is in tidal condition. In tidal condition, there will be current flowing in both directions. So you see in this direction, current flow is more stronger. So the cross bedding is formed like this. So during reversal of current, it will erode this cross bed. It will partly erode the cross bed. So then again, when this current condition will emerge, then it will again produce cross bed over a eroded surface. That is called the reactivation surface. So all these characteristics that are found in the reactivation surface condition. So answer will be D. So which one of the following assemblies correctly represents the coated non-skeletal allochems in tabular? So we have 4 types of coated non-skeletal allochems. One is your words Fissureds, oncoids, and these are cortoids. These are the four coated bed, from which bed is spherical, having concentric internal structure. Fissured is larger than beds. When oncoid, it has non-concentric layers. Coated, it is a rounded grain skeletal matter that have a coating of micrite. So all are considered as coated beds. Next comes to the same classification question. Which one of the following pair is not correctly matched? The backstone is date supported. It is allochotonous limestone. It is correct. Bindstone, it is autochotonous limestone with encrusting by organism. It is your coral type of thing, that is bindstone or French stromatolite of thing, stromatolites. Then floatstone, allochotonous limestone with less than 10% grain and no limestone. So floatstone, it is having a mod supported thing. So it has greater amount of mod. So this is the incorrect option. Next one, it is allochotonous supported limestone. This is correct. The answer will be C. Which one of the following arrangements correctly represents a sub-environment from landward to seaward? So from landward, first thing you will get swash zone, then you will get surf zone. So from land, you will first get backshore. You will first get backshore, then your swash zone, where the wave generally just moves to the top, then it will go back. That is your backwards condition. Generally, where we roam near the beaches, the water comes to a slightly sloping up region. Then it is again returned to the ocean. So in that region is called as a swash zone. Then you will get some surf zone. The water is generally in that region. The water is surf. So that is your surf zone. Then below that you will get your breaker zone, where the wave will touch the wave base and it will start to break. And before that, your swelling zone, where the wave also interact with the wave sea floor. That is your swelling zone. From that, the wave started to interact, and the breaker zone it will break, and in swash zone it will carry material, and in surf zone it will also erode and deposit in there. So the sequence from landward to seaward, if you see, first that will be backwards, then swash zone, then surf zone, then swelling zone. So in swelling zone you will get your breaker zone. Okay. So answer will be A. Then match moraines. It is obviously related to glacier. So moraine it is related to glacier. Then natural levees it is related to meandering cross strata. Hummocky cross stratification it is related to shelf zone, and berm it is related to shore zone. So A is 4, B it is 3, C it is 1, D it is 2. It will be B. A bayhead delta develops commonly. So a bayhead delta, it is a type of delta. Remember, it is mostly dominant in wave-dominated estuary. It is dominated in wave-dominated estuary. In tide-dominated estuary, or that is tide-dominated, is same as macrotidal course. Macrotidal course is also tide-dominated. So it is you will find estuarine. That is our Ganga Brahmaputra delta. That is the estuarine delta. So Bayhead delta, it is produced in wave dominated estuary. The answer will be wave dominated estuary. So which one of the following is the characteristic of pressure solution process during diagenesis of carbonate rocks? So during diagenesis, the transformation of minerals and physical compaction occur. So if you are saying there is a pressure solution action, there must be a suture contact. Always remember, a pressure solution is always associated with a suture contact. So the formation of interpenetrating suture contact, it is a characteristic of a pressure solution condition. It will be like this is a grain and there will be a sutured contact like this in between them. So it is because of pressure solution. A sediment which contain grains of various size in nearly equal amount are said to be. So if you say the sediment which contain grains of various size but they are nearly are all of equal amount, then it is called as a unaccepted condition. It is called as a unaccepted condition. Which of the following is a variety of sandstone that is exponentially rich in mica dispersed in parallel and subparallel layer? So if we are saying that is very richer in mica, that means it is easily breakable in a particular direction. So from this rock, your flagstone, always remember it is very richer in mica, and if you break the flagstone, it will break in parallel sheets. It will break in parallel sheets, which is generally used in pavement to construct pavement. The answer will be flagstone. Then freestone, it is a type of rock which is consists of very finer grain and it can cut in any direction. So it can cut like unlike one flagstone which can be cut, which can be break in a particular direction. But a freestone, the name is given because it can cut in any direction. You can cut it in any direction. You can take, you can give any shape to it. So it is freestone. Then comes to ganister. Ganister is a very hard fine grained sandstone, or you can say so. It is also metamorphosed to quartzite, but it is contain 98% SiO2. It is contain 98% SiO2, so that it can be used in blast furnace because it consists of fine grained grains and consists of a single composition. So it is greenstone. So answer here will be flagstone. Then a multi-laminated and a fissile rock capable of breaking into small flakes. So fissility is the characteristic of shell. In organic means you know it is between quartz and feldspar, where eye-shaped feldspar surrounded by cores. Then sandstone, which is a common type of sedimentary rock. Then micaceous quartzite, which is also a metamorphic rock. Then on account of charged surface of clay metals, their interaction with saline water leads to crumpling into aggregates of randomly oriented clay flakes. So this is a phenomenon that occurs in marine condition where clay metals they are interact with the saline water. That is called as your flocculation. You'll find it in mostly marine condition. The answer will be flocculation. Which one of the following bedding is marked straw or scoop shaped? There is a festoon bedding. It is the other name of you can say straw cross bedding. Then which one of the following is a grain supported limestone that also contains some micrite mud matrix? Same question we encountered in previous year. A grain supported limestone that also contain micrite matrix. That means grain supported micrite is from finer grain. So you are talking about grain supported means we have either grainstone or packstone. So from which packstone it contain mud, grainstone it doesn't contain mud. So answer will be again packstone because it contains some mud. Next move to during diagenesis, the process of interstratal solution leads to the process of interstratal solution. So the interstratal solution it will dissolute material. It will dissolute material interstratal solution that occur because of pressure solution also that will expel water when physical compaction also occur. That also produce your that also produce water. So during diagenesis, this process of interstratal solution, it will produce selective dissolution. It will produce selective dissolution at the grain boundary, okay, of less stable framework grains. So it will produce, it will start to dissolve grain from the grain boundary, and it will always start to dissolve the less stable framework grain. So the less stable framework grain they will selectively dissolve. So this will be the condition that occur through interstitial solution. The answer will be B. Then let's take the other option. Dissolution of one mineral and precipitate on another mineral simultaneously. It doesn't occur simultaneously. There will be alteration, there will be precipitation, but they are not occurring simultaneously. Alteration of one mineral into other by the process of dewatering. Dewatering doesn't uh, alter minerals, it just expel water. Formation of two minerals of contrasting physical and chemical environment. It is not also the correct option because interstitial solution it cannot produce two minerals of contrasting physical chemical environment because the diagenesis that occur in a particular environment. You have carbonate environment diagenesis, you have siliclastic environment diagenesis. So it will not occur in two different minerals. So answer will be B. Which one of the following rock types may also be formed along planes of movement in the crust? So it is saying what type of rock will find in a faulted rock, faulted region. So in a faulted region, from these rock you will get breccia, faulted breccia. You will get faulted breccia. Then reef current, the reef current that occur that form because of when two longshore current meet and they start to move towards the sea in a you can say a very low topographic barrier region or low topographic bar region. So these are they move seaward as narrow near surface current. Deep currents are they move seaward as narrow near surface current. So the replacement of dolomite rhombs by calcite. So if dolomite it is replaced by calcite, then it is called as de-dolomitization. It is called as de-dolomitization. Dolomitization is a formation of dolomite. If dolomite is again replaced by calcite, we will say de-dolomitization. Then the Dead Sea provides. Dead Sea is a restricted basin type of thing you can say, where you will get hypersaline condition, where evaporation is more than precipitation or infiltration. So in that you will get evaporite deposition, which condition you will get in the supratidal region, in Sabkha region, what we'll say. So there we will get most remarkable deposits of evaporite from the ancient past. So it is deposited from ancient time. So you will get most remarkable deposit of evaporite from ancient past. Answer will be B. Then the difference between carbonate and siliclastic sediment. The difference between carbonate and siliclastic sediment. The carbonate sequence occurs in shallow tropical environment while silicates occur worldwide at all times. It will be correct because carbonate sequence they are derived from organisms. Organisms are more abundant in shallow marine environment. So it will be correct. The carbonate sequence occur at deep marine environment. It will not be correct because in deep marine environment there is a condition that is called as CCD, carbonate compensation depth. Below that you will not get any carbonate deposition. Then answer will be A. Let's take another other options. Both carbonate and siliclastic occur at same deposition element with different grain size and texture. It can be occur in a mixed self condition, but it is not that much appropriate here because the first option is more appropriate. The carbonate deposits result from shallow water bodies from interaction of currents and waves, while siliclastic results are only deep and calm water deposition. It is also incorrect. Then also the grain size interpretation in siliclastic rock is much simpler than carbonate and evaporite. It is because the grain size interpretation of siliclastic rock, it is the siliclastic rock, it is during your diagenesis, the siliclastic rock doesn't change much, but during diagenesis, the carbonate rock, it always destroys its original shape and size. So that's why the grain size interpretation of siliclastic rock is more simpler than carbonate rock. The answer will be the diagenesis condition of carbonate rock, which that destroy the original grain shape size. So it will be A. Then comes to hard ground. So hard ground, these are formed by organical deposition or evaporite deposition, or you can say your precipitation deposition. So these are you can say microscopic erosional surface on the underbed or bedding plane formed by natural cast of erosional features. It is incorrect. Vortex erosional typical at the base of the turbulent current. Hard ground, it is in the self region. It is found in the self region. Then hard grounds, it is actually organically bored surfaces with incrusted with fossil in growth position. This is called as a hard ground. So because hard grounds are, you can say, lithified sea floor that made up of cemented carbonate layer. It is made up of cemented carbonate layer. So generally it is found in carbonate horizons because if there is more cementation or compaction, you will get hard grounds. And hard grounds, they are also characterized by this boring structure. Here answer will be C. In sedimentary rocks, the beds that contain internal layers that are essentially parallel to the bounding surface are said to. If internal layers, they are essentially parallel, they are called planar stratified. They are called planar stratified. Ecrobasin dominated by deep vertical burrow in tidal zone named as. So there is just colithos. They have deep vertical burrows. They are found in tidal region. So they for do these or construct this deep vertical burrow to prevent from these because they are found in intertidal condition. So there is a chance of desiccation during low tide conditions. So to prevent from desiccation, they always produce deep burrows. The answer will be scolithos. Then the clastic ratio of lithophysis. So clastic ratio, it is calculated by clastic by non-clastic. Clastic by non-clastic. So here clastic by non-clastic is conglomerate sandstone mudstone. It is clastic, limestone, dolomite, evaporite and coal. Those are non-clastic. Answer will be D. Then texturally mature or textural maturity of sandstone is determined by the textural maturity. It is determined by first thing the relative abundance of stable unstable. It is indicates the mineralogical maturity. It indicates the mineralogical maturity. Then the ratio matrix of well-defined grain under hydrostatic condition. It is not the option. The relative abundance of matrix and the degree of rounding and sorting of removals. So it is your correct option, because the textural maturity always depends upon the roundness of the sandstone and the percentage of matrix. If it is less than 5% or less than 50%, what we say RNAs, so those are more mature. The quasi-RNA is more mature, which is rounded and it contains very less percentage of matrix. So answer will be C. The proportion of coarse grain sediment to fine grain sediment, it is not proper for maturity. Then vertical profile model of a cyclic sequence in evaporite bearing sediment, reflecting a sensitive response of evaporite environments. So there is a vertical profile model of cyclic sequence in evaporite bearing sediments. So what will the response to the evaporite environment? So first thing, the climate change, brine level and water distance. So in that condition, the water chemistry or climate change or brine level all will affect the evaporate sediment deposition, because climate change has the effect of it will accelerate the evaporite deposition by warming of the brine level, that is the salt level. If it should increase, then there will be more precipitation, and that brine level is related to water chemistry. So these three things are sensitive response to the evaporite environment. So answer will be A. The non-clastic sediment composed of microcrystalline quartz found in both bed and the nodules of limestones and sandstone is known as. So microcrystalline quartz, from this your microcrystalline quartz is chert, and it is found in both nodule condition and bedded condition. The two types of chert also, one is nodular chert, another is bedded chert. And so it will be chert. Which one of the following zones of carbonate diagenetic depth occurs below the calcite compensation depth? So from this option you can say zone of no carbonate. So below CCD you will get zone of no carbonate. Simple. Which one of the following may caused by carbonic acid rich waters produced by the devolatilization of coal beds? So remember the devolatilization of coal beds, it will produce kaolinization. It will produce kaolinization. Alteration, three type of alteration. Then also reef and carbonate slope builds up have steeply dipping sediment water interface much steeper than the angle of repose of loose talus. It is due to, because these reef carbonate, those are bind stone, those are frame stone. Like you see, if you gather loose sediments, they have a very less angle of repose. If you gather consolidated sediments, suppose you will think of a wall, of a cement wall, it is very steeper. But if you try to make a loose sediment, you will use loose sediments to create a wall, then that will be not that much of steeper like a cement wall. So the cement wall, it is because of this binding property, because of this, you can say they are they are bound with each other. So that's why they can produce a greater slope. So that is the condition in case of reef carbonate slope, which consists of bind stone. That is frame stone, bind stone, all are found in reef. So that's why they produce a steeply dipping sediment water interface. Whereas in talus condition, they are loose fragment. They will produce loose condition. So it is because of organically binding and early cementation. They produce steeper slope. So this was your question, that is from 2023 to 2020. And 2024 question, that is already a video. So most of the questions from sedimentary are from classification. So Dunham's classification, sandstone classification, then some of the questions from the structures, and there is a marine condition, environment condition, and there is some question from carbonate sediments and carbonate, diagenesis. So all these parts are very important for GSA. So thank you everyone.